Okay, good morning, grade 9. Our lesson today is chapter 5, lesson 5 in Algebra 2, solving rational equations and inequalities. A rational equation is an equation that contains one or more rational expressions. A rational equation is an equation that contains one or more rational expressions. To solve a rational equation, start by multiplying each term of the equation by the least common denominator, the LCD. So to solve a rational equation, you have to start by multiplying each term of the equation by the least common denominator, the LCD, of all the expressions in the equation. This step eliminates the denominators of the rational expressions and results in an equation you can solve by using algebra. Eliminate means cancel. Okay, so let's solve example 1 before we watch the video. Solve the equation x plus x 8 over x equals to 6. So the denominator here is x. So I'm going to multiply the three terms by x. The first term here, which is x, let me annotate here. The first term here, which is x, and the second term, which is 8 over x, and the third term here, which is 6. I'm going to multiply them all by the denominator here, which is x. Okay, here is the denominator. So I'm going to multiply them all by the denominator, which is x. So I'm going to multiply x by x and 8 over x by x. And in the other side, I'm going to multiply 6 by x. So now x multiplied by x will be x squared, and x will eliminate or will cancel the denominator here, so it will be 8. And in the other side, 6 multiplied by x will be 6x. Now I will bring 6x in the other side by subtracting 6x in the two sides. So here it will be negative 6x and here it will be 0. So now I got the normal equation that I can factor. X squared minus 6x plus 8 equals to 0. So 8. I will choose two factors. When I multiply them, they will be 8, and when I add them, they will give me the middle term, which is negative 6. The two terms are negative 2 and negative 4. Negative 2 and negative 4, when I multiply them, the negative and negative sign will cancel each other and will become 8. And negative 2 and negative 4, when I add them, they will give me negative 6. So negative 2, x minus 2 is equal to 0, so x is equal to 2. And x minus 4 is equal to 0, so x is equal to 4. So if I read here the steps, multiply each term by the LCD, which is x. Simplify, note that x is not equal to 0, write in the standard form, then factor here, then apply the zero product property, then solve for x. Then if you want to check your answer, you can substitute x by 2 or substitute x by 4, and you will get your answer should be 6. If you substitute x by 2, your answer should be 6. Or if you substitute your answer by 4, your answer should be 6. Okay, so let's watch the first video here.
We actually see fractions in the denominator in which there are variables, unknowns. How do we untangle that? Well, it turns out that we just use all the properties that we know about rational numbers and apply them to these objects. Let's take a look at an example. Suppose we want to solve x plus 4 over x equals 5. Well, what should we do? Well, the thing to think about here is to realize that, at least in my case, not a big fan of fractions. Okay? I mean, fractions are fine, but not a big fan. So I'd like to try to get rid of the fractions. And so what I'd like to do is to multiply through. Now we can multiply through by the LCD, the least common denominator. But in this case, it's really easy to see that if I multiply both sides through by x, then even though I'll have an extra factor of x everywhere, at this term here, that will actually cancel with the x downstairs, and actually I'll have no more denominators. Look, Mom, no denominators. It's cool. So let's try it. So what I want to do is I want to take this entire expression and multiply both sides by x. Okay, so I multiply both sides by x. Now I've got to distribute, of course. Whoop, whoop. And what I see here is x squared. And now x times 4 over x, the x's actually can be simplified. Common factor on the numerator and denominator. And so I'm just left with 4, which was the whole point of multiplying both sides by x. If we ended up with still rational expressions here, then we know that something didn't quite go right, because the whole point of multiplying through both sides by x is to actually get rid of the denominator. Okay, excellent. Well, now what? I see that I have a quadratic. That tells me I should be thinking factoring. I should get everything equal 0. So I'm going to subtract 5x from both sides. And when I do that, I see x squared minus 5x plus 4 equals 0. You can see how the 5x on this side migrated to this side with a minus sign, and then the 4 is still here. And now the question is, can this be factored? Well, x, they're both going to be the same sign, and they're both going to be negative signs. And I need to have a product of 4 and the sum to be 5, and there we have it. So there's two possible answers. Either x minus 4 equals 0, or x minus 1 equals 0. If x minus 4 equals 0, that means that x equals 4. If x minus 1 equals 0, that means x equals 1. So we have two solutions, and we want to actually see if these two solutions make sense by checking. So let's check. Check, please. Check. Let's take a look at 4. If I insert 4 for x in the original equation, what do I see? I see 4 plus 4 over 4. Well, 4 over 4 is just 1. 4 plus 1 is 5, so checks. So I see 4 plus 4 over 4 equals 5, checks. What about when x equals 1? Well, then I have 1 plus 4 over 1. Well, 1 plus 4 over 1. 4 over 1 is just 4, plus 1 is 5, and that checks. They both check. So we have two answers. X equals 4, x equals 1. Now, you look at this and say, hey, I wouldn't have guessed there were two answers because there were no squareds there. Well, you're right. In the original question, there were no squares. But notice that when we ended up actually rewriting it to an equivalent equation, the square appeared. So actually, invisible here, there actually are, in fact, two answers, because really, this is a quadratic in disguise. Quadratic in disguise. So you got to be careful. When you clear the denominator, all of a sudden, you start to see maybe more than one solution. There's more than one solution that meets the eye.
Okay, as you see here, girls, that when I substitute x values, I got a solution. I got an answer. Okay, because it is the opposite of what we're going to learn now. Because an extraneous solution is a solution of an equation driven.
Hello, Miss.
Oh, we got a new visitor today. Oh, we got Tala. Hello, Tala. I miss you so much, you and Ayla. So I'm so happy that I have two visitors today. Yes, 3 weeks I was talking to myself.
Miss, we miss you more.
Hello.
No, we miss you more.
Yara. I wish Yara also will come. Tell her Miss Amira is telling you that she miss you so much and she wished to listen to your voice.
Okay.
Okay, let's continue. So, as I told you that in the original solving rational equation that we learned in example 1 is opposite to the one that we're going to learn now, which is called an extraneous solution. The first one, when we got the value of x and we substitute the value of x in the original equation, we got 6. We got the answer. But here, in the extraneous solution, when we get the value of x and we're going to substitute, there will be no solution. the solution will be equal to 0. Let's read it and let's solve the example and we will learn more. An extraneous solution is a solution of an equation derived from an original equation that is not a solution of the original equation. When you solve a rational equation, it is possible to get an extraneous solution. Okay, girls, when you solve a rational equation, it is possible to get an extraneous solution. It is possible to get, okay, and you will know. And there will be no title that will tell you solve and you will get an extraneous solution. No, you will know by yourself that it is an extraneous solution. These values should be eliminated from the solution set. Always check your solutions by substituting them in the original equation. Always check your solutions. You must always check it. Okay, girls? Let's move to the next page and see the example. Okay, extraneous solutions, solve equations. The question is solve equations, okay? How we solve equations here in the rational equations? We multiply by the LCD, but we multiply by the denominator. The denominator here is what? X minus 3 and X minus 3. So I'm going to multiply here. Let me draw here. Here I have the first term. And here I have the second term. And here I have the LCD that I'm going to multiply with, which is X minus 3. So I'm going to multiply here by X minus 3 and I'm going to multiply here by X minus 3. X minus 3 will eliminate or will cancel X minus 3 here, and X minus 3 will cancel X minus 3 here. Why I'm doing this? Because I want to return it back to an original equation that I can easily solve. So 3x is equal to 2x plus 3. If I will subtract minus 3 from here and minus 3 from here, if I will, divide 3x here and divide 3x here and subtract here and so on, finish all my steps, x will be equal to 3. How I will know if it is extraneous or no? By checking my answer. If I put here 3, and if I put here 3, the denominator will be equal to 0. Have you ever seen in your life that the denominator is equal to 0? No, you haven't ever seen it that the denominator will be equal to 0. You know why, girls? Because there is nothing in math called denominator is equal to 0. Nothing in math called the denominator is equal to 0. Okay? 0 over a number, yes, it is equal to 0, but a number over 0, no, nothing is in math is called over 0. The denominator is 0. So the solution, which is x equal to 3, is extraneous because it makes the denominator of the original equation equal to 0. Therefore, the equation has no solution. Check, substitute 3 for x in the original equation. So you will get 9 over 3 in the left side, and in the right side you will get 9 over 3. Division by 0 is undefined. Okay, girls? Division by 0 is undefined. Okay, let's solve another one. Here I have two different denominators. I have here x minus 7 and I have here 2. So which one, teacher, we're going to choose to multiply all the terms with? I'm going to choose both. I'm going to choose both because I want to eliminate all the denominators, so I will find the simplest equation so I can get the value of x. I will choose all the denominators, all, to eliminate them so I can get easily the value of x. So I will multiply here the first term by x minus 7 multiplied by 2. And I will multiply the second term here by x minus 7 multiplied by 2. And I will multiply here the other side by x minus 7 multiplied by 2. Why, teacher, x minus 7 multiplied by 2? Because the denominators here, if I look at the three denominators here, I find x minus 7, and x minus 7, and 2. If I find 3, I will multiply by the 3. If I find 2, I will multiply by the whatever I will find it in the denominator, I will multiply with. So here, this one, x minus 7 will eliminate x minus 7, and 2 will be left here. 2 will eliminate the 2, and x minus 7 will be left here. X minus 7 in the other side will eliminate x minus 7, and 2 will be left here. Then simplify. 2 multiplied by 2x minus 9. The other term, x and x minus 7 is equal to 5 multiplied by 2. Then I'm going to distribute 2 to 2x and 2 to negative 9, then x to x and x to negative 7, and 5 and 2. So it will be 4x minus 18 plus x squared minus 7x, because I have negative sign here, is equal to 10. Okay, then I will order the like terms together. I have x squared here, and I have 4x minus 7x, so it will be negative 3x. And I have here negative 18 and 10. If I subtract negative 10 from the two sides to get rid of this 10, so it will be negative 28 equal to 0. So now I got the simple form that I used to answer from it and to solve x from it. So left for me the normal step, which two factors, when I multiply them together, I will get 28, and just wait 1 minute, girls.
Miss, take your time.